Hello students, welcome to second session of graph theory. This is the second session of unit 1. In this session we study about incidence and degree, adjacent edges and adjacent vertices, some examples and theorems on degrees. Definition of incidence and degree. When a vertex Vi is an end vertex of some vertex Ej, Vi and Ej are said to be incident with or incident on or incident to each other. Adjacent edges. Two non-parallel edges are said to be adjacent if they are incident on a common vertex. Adjacent vertices. Two vertices are said to be adjacent if they are the end vertices of the same edge. Consider this graph. Here the edges E2, E3 and E1 are incident on vertex V2. Similarly, edges E2, E6, E7 are incident on V4. So this V4 is a common vertex for E2, E6 and E7. So these three edges are adjacent. Similarly, E1, E2, E3 have common vertices, vertex V2. So E1, E3 and E2 are adjacent edges. Here see E3, E4, E5 are incident on V1. V1 is a common vertex. So these three edges E3, E4, E5 are adjacent. Similarly, E4, E5, E6 is incident on V3. So these three edges E4, E5, E6 are adjacent. Here V5, the vertex E7 is incident on this vertex V5. So here E5 has only one edge incident on it. Such a vertex is called a pendant vertex that we study later. Now, edges E1, E2 are adjacent. See here, E1 and E2 are adjacent because they have a common vertex. But the edge E1 and edge E4 are not adjacent because here edge E4 has end vertices V1 and V3. E1 has end vertices V2, E2 itself. So no common vertex. So E1 and E4 are not adjacent. Now consider about the vertices. Vertices V4 and V5 are adjacent because there is an edge between V4 and V5. Vertices are adjacent means there is an edge between that two vertices. Here see, vertices V1 and V2 are adjacent, but vertices V1 and V4 are not adjacent because there is no edge between V1 and V4. Similarly, the vertices V1 and V5 are not adjacent because there is no edge between V1 and V5. Similarly, vertices V2 and V3 are non-adjacent because there is no edge between V2 and V3 and so on. Definition of a degree of a vertex. The number of edges incident on a vertex Vi with self-loop counted twice is called degree of vertex Vi denoted by D of Vi. Now here is a graph with 5 vertices V1, V2, V3, V4 and V5. The 7 edges E1, E2, E3, E4, E5, E6 and E7. So we find out degrees of each vertices. Now degree of V1 we have to find out, that is, here see E3, E4 and E5 are the three edges incident on this vertex V1. So degree of V1 equal to 3 because there are three edges incident on it. Now to find out the degree of V2. Here V2 is incident with self loop E1. So it counted twice. Now E2 E3 are other edges incident on V2. So the degree is 1, 1 plus 2. That is 1 plus 1 plus 2 means 4. So degree of the vertex V2 is 4. Now consider the vertex V3. There are 3 edges E4, E5, E6 incident on V3. So degree of V3 equal to 3. Now consider V4. There are 3 edges E2, E6 and E7 incident on V4. So degree of this V4 is also 3. Now consider the last vertex V5. There is only one edge E7 is incident on it. So degree of Vi is 1. Now we have a result. What happens if we add all these degrees of all the vertices? Here we have a note. Since each edge contributes 2 degrees, the sum of the degrees of all vertices in a graph is twice the number of edges in G. That is, d of V1 plus d of V2 plus d of V3 plus d of V4 plus d of V5, that is equal to 3 plus 4 plus 3 plus 3 plus 1, that is equal to 14. 14 means 2 into 7, that is 2 into the number of edges, that is same as 2e means number of edges, twice the number of edges. There are 7 edges. We have the degree, sum of the degrees of all vertices is 14. Odd and even degree vertices definition. If the number of edges incident on a vertex Vi is odd, then d of Vi is odd and Vi is an odd degree vertex. If the number of edges incident on a vertex Vi is even, then d of Vi is even and Vi is an even degree vertex. Consider the graph with 5 vertices and 7 edges. We know that degree of V1 is 3, degree of V2 is 4, degree of V3 is 3, degree of V4 is 3 and degree of V5 is 1. Here the only vertex with even degree is V2, so V2 is even or V2 is even degree vertex and all the vertices V1, V3, V4, V5 except V2 have degrees odd. So all the vertices V1, V3, V4, V5 except V2 are odd degree vertices. Theorem: the number of vertices of odd degree in a graph is always even. Proof: if we consider the vertices of a graph with odd and even degrees separately, then we get sigma I equal to 1 to n d of Vi. That means sum of all the degrees of vertices is equal to sigma d of Vj of even degree vertices plus sigma d of Vk of odd degree vertices. That implies 2e equal to even number plus sigma d of Vk of odd vertices, because here sigma I equal to 1 to n d of Vi equal to twice the number of edges, that is 2e, and sigma t of Vj of even degree vertices is always even. That implies sigma d of Vk of odd degree vertices equal to 2e minus an even number. So we get the subtraction of two even numbers, that is also an even number. So summation of the degrees of all vertices of odd degrees is an even number. So we have the result. The number of vertices of odd degree in a graph is always even. Problem: can there be a graph consisting of the vertices A, B, C, D with degrees? D of A is 2, D of B is 3, D of C equal to 2, D of D equal to 2. Why? Answer is no, because D of A plus D of B plus D of C plus D of D equal to 2 plus 3 plus 2 plus 2, that is equal to 9. 9 is odd, which is impossible since the sum of the degrees of all vertices is always even. Thank you for watching this video. Thank you all.